Welcome to Olex2. In this video I'd just like to show you the very basics of getting started with solving and refining small molecule crystal structures, X-ray crystal structures with Olex2. The example dataset that we ship with Olex2 is the Sucrose molecule, which is also what you see when you open Olex2 for the first time. And it's this first sample here. There are other samples we provide, but this is a good start. So this is a finished structure. Normally, of course, you don't start with a finished structure, but you start with the INS file and the HKL file, which your diffractometer produces and which you should be provided with in order to proceed with Olex2. So what you've got is just those files, and I can simulate that by typing reset here. We are now at a blank slate. We've got an INS file that contains information about the unit cell and potential element types, and we've got the HKL file, which is the list of reflections. So if you haven't got that, Olex2 is not for you. You need to start with an HKL and an INS file to proceed. The first step in a structure solution or structure determination is to solve the structures. In Olex2, there are a number of solution programs that you can address. There is the Shellix programs, there is Superflip and Olex2 Solve. Now, if you just install Olex2, it will only have Olex2 Solve. The other structures must be on the system path for it to be visible here. And this is a slightly different subject, and I'll get to this at the end. So, for structure solution, I will choose Olex2, George Sheldrick's latest fantastic program, and I click Solve. What this is doing now, it's solving the structure and then it's showing you the structure on the screen. It's not completely right. That should of course be an oxygen, but it's not a bad start. You notice in Olex2 there's sort of text output is in the background. You can type text and that will give you a transcript of what has happened in a text box, which you can then copy and paste and basically look at without interference. And in order to keep the screen a bit tidier, I'm going to type lines. I'm just going to look at 3 lines so we see something happens, but we don't actually get distracted by it. So what this is now showing is a structure solution from Olex2 where some atom type assignment has been made. So Olex2 thinks this is oxygen, oxygen, that's red. We can hit F3 and then we can see the labels. That's O, 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 and these are carbons, 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 and so on. So this is not necessarily correct, but it's a good starting point. So what we do in the next step is we're going to refine this. And again, there are various refinement programs out there, and I recommend ShellXL, and make sure it's the latest version of ShellXL. And you hit refine. What happens at this stage is your model, or the model that the structure solution has produced, is compared to your data, and the refinement will move things about in your model, but it will also give you an agreement factor, an R factor of how well your model matches the data that you've got, your HKL data. And that match isn't bad, it's 9%. And the structure is here, but one thing that you might notice is there's a couple of very darker looking peaks around here, and they're in the order of 1, so they're quite strong. And that's a hint, another hint that this is not actually an oxygen, but let's just keep that wrong for the moment. You also notice some of these balls are slightly bigger than others, and that's the UEQ value that's shown as a sphere. So let's go anisotropic. So what we do, we click on this to make this whole thing anisotropic. The R factor is dropped quite a lot, and what's quite clear now is that this thing is a triangle. It's not one of those rugby ball shaped things, and that's because this is really an oxygen. So we click on this and type name O, or you could just click on the O here and then change the atom type that way. Control R will refine. And now the R factor is dropped by another %, and that's because we're now getting very much closer to what we actually expect. So those brown peaks, which are termed Q peaks for electron density, there's a charge here, they're the hydrogens, so you can see them. I would still recommend to just add the hydrogens geometrically. Click on this, it puts the hydrogens in, and because this box is ticked, it will then also automatically refine. And the R factor dropped significantly again, and now the biggest peak is only 0.3. We can click on this to see which peak it is. And the interesting thing is it's actually this peak here. I hit the escape key on the keyboard, and that's because that hydrogen really is pointing at that. So these are much too close. If I select both of those and hover the mouse over the selection, I see this is 1.3. That's impossible. They're way too short. So we need to get rid of this. So the thing to do is to delete that and then type HAdd or press that button here again and Ctrl R for refine. Now you're still seeing a lot of these peaks, so we could just do refine. Just say let's want 5 cycles and only see 4 peaks, so refine 5, 4. This is now remembered. I can use the up key and it will repeat the same command as before. So the biggest peak is now 0.2. That's really absolutely nothing. At this point we are convinced that there aren't any missed hydrogens or there's anything wrong with the non-hydrogen atoms, so we can press Ctrl Q, which I'm going to do in the keyboard, and that shows us those Q peaks with bonds, and another Ctrl Q, and then all the Q peaks are hidden. It's the same as pressing the Q button here. It shows the peaks without bonds, with potential bonding distances, and it hides them. And that's it. We've got the structure. The acta command is on, so we get a CIF file. There are other options here. You can have no acta, so the acta isn't shown. It will not give you a CIF file, or no HKL is produced. That's a slight thing. This goodness of fit is looking good, even though the weighting scheme isn't switched on. We can switch the weighting scheme on by clicking on this and Ctrl R again to refine. And we do this a few times until this turns out to be green, and that means the weighting scheme has settled, the R factor is dropped. Now the FLAG parameter is not refining very well. We are at 0.1, minus 0.1, but with an ESD of 10. So that means we know nothing about the absolute stereochemistry of this structure. Okay, so a check at the end is we click on Info. Click on bad reflections and we can see a list of reflections that really don't fit, and there aren't any. That's good news. Reflection statistics, we can look at some output here. First of all, I over sigma versus resolution is always an important one. So all the reflections that we're using, the mean I over sigma should be above 3. And they're all the case. So we're not going to omit any data here because we still got real data here, and there's no point omitting that. We can then also look at the FOPS versus FCalc. That's effectively showing us the R factor in a graphical way. So there's a bit of trailing off, so maybe a bit of extinction going on, but that's probably not worth dealing with. And that's it. We've got this structure here on the screen. We can go back to work and look at the report area where there's a lot of options here. And in the end, we can click on Edit CIF Info, and this is all the information that will be merged into your final CIF file. You can edit this field in this window. You can add information, you can take information away, and of course you can look at the merge CIF, which will then show you the entire CIF file, included the embedded HKL data as it should be nowadays. So I just recapped this very briefly. We solved the structure by hitting solve. We refined the structure by hitting refine. We making things anisotropic by typing anis and Ctrl R for refine. Then we realized there's something going on here. We could also have looked at the map. The map is a very powerful tool. We click on Toolbox Work, Electron Density Map, and that clearly shows as well there's some hydrogens missing. We know that, but clearly there's something going on. Not enough electron density has been assigned here. We're clicking on this and we type name O, refine this again, and HAdd to add the hydrogens to this. Ctrl R, and then we realize the biggest peak is sort of over here and there's a clash here. One thing we could have done, we could have selected the offending group and then go fit, and then we can right click on this bond which will activate this bond, and then we can just move that. Oh, that's the wrong one. I can just with the shift key I can move that hydrogen over there and hit refine. and I end up at the same place as if I had done the automatic replacement. Control Q to switch it off. Okay, so how do you get Shellix integrated and also Platon, which is an extremely useful tool provided by Ton Spec, and we're all grateful to Ton for providing this fantastic tool. These tools, Shellix, Superflip, Platon, they must be on the system path. I realize that the system path is a funny concept. However, it's really just the folder. You need to let Olex2 needs to know in which folder to look for these things. And you can add this either to the system path if you know how to do this, or you can just install Shellix and put the path, the folder name, and the whole path to the folder name into this field here, and after restart, Olex2 will find your Shellix installation. Please don't use any Shellix executables that you inherited from anybody. Just go to George Sheldrick's website and the Shellix website, register yourself, and then download your own versions and be fully compliant and legal with using the right executables. Also, please make sure to use the latest version of Shellix L. It's, I think, 2016/6, so that's the latest version, and it's very important to keep this up to date. Okay, this is in a nutshell how to do a simple structure and how to get started with Olex2, and I hope you find this useful. Please use the comments and at the end of the YouTube video and let me know what you would like to know, if I'd missed anything out, if there's anything you would like to see here, and I'm happy to make another video. Thanks for using Olex2.